Unit 12, Solving Trigonometric Equations. In example 1, we have 2 sine x minus 1 equals 0. We want to find the values of x such that x is between 0 to 2 pi. So we can include 0 and go all the way up to 2 pi. I'm going to start by isolating the sine of x. So think of PEMDAS. Please excuse my dear Aunt Sally. And I'm an I that contains the sine of x. Is there any adding or subtracting? There is. Opposite of subtracting 1 is adding 1. Opposite of multiplying is dividing. And now I'm going to grab that unit circle and I want to ask myself, where is the sine value equal to positive 1/2? I know sines are positives in quadrants 1 and quadrants 2. If you need a quick reminder, remember all-star trig class. All things are positive and sines are positive in quadrants 1 and 2. Sine, being the second value, is positive at pi over 6 and at 5 pi over 6. So x is equal to pi over 6 and 5 pi over 6. Also notice that we do want to identify the values of x in terms of radian measurements. Let's look at example number 2. Example number 2 is going to follow the same procedures as example 1. I want to isolate the tangent of x. Right now, negative the square root of 3 is being multiplied by this quantity. So I'm going to divide by negative square root of 3, divided by negative square root of 3. The tangent of x is equal to negative. Now this negative sign can be placed anywhere in top, in the middle, or bottom as long as there's one negative. 1 over the square root of 3 with a negative sign in front. Mathematically this isn't wrong, but it's not in proper form. And so I'm going to multiply both the top and the bottom by the square root of 3. I have negative square root of 3 over the square root of 9. And I know the square root of 9 is equivalent to 3. So I'm going to go back and I'm going to find where is the tangent equal to negative radical 3 over 3. Keep in mind, all-star trig class tells me that tangents are positive in quadrants 1 and in quadrants 3. I want to know where the tangent is negative. So I'm looking into quadrant 2 and quadrant 4 at this time. Now, here's where we can use these reference angles. I can see the reference angle of 30 degrees, or pi over 6, results in a tangent that's radical 3 over 3. So other reference angles would be 5 pi over 6 and 11 pi over 6. These both have a reference angle of 30 degrees, and they lie in quadrants 2 and in quadrants 4. So x equals 5 pi over 6 and 11 pi over 6. Let's take a look at example number 3. Let's isolate the secant of x. Opposite of multiplying is dividing. And now I'm going to put it in proper form. Proper form means there's going to be no radical in the denominator. Times the square root of 2. The secant of x is equal to 2 square root of 2 over the square root of 4. I know the square root of 4 is equivalent to 2. The 2's cancel into 1's, reduce into 1's, and now I'm asking myself, where is the secant of x equal to the square root of 2? Now let's look at our unit circle. Notice that I am identifying the primary trig functions, sine, cosine, and tangent. And right now I have a secondary trig function. So let's translate this into an equivalent primary trig function. I know that the secant of x is equal to 1 over the cosine, or the cosine of x is equal to 1 over the secant. They're reciprocals. So I can write this, if I come back up here, I know that the cosine of x is equal to 1 over the square root of 2. And so in order to write this in proper form again with no radical on the bottom, I have the cosine of x is equal to 1 times the square root of 2, which is 2. 2 times 2 is 4. And we know the square root of 4 is 2. All right, this looks like something I can find. So looking at going one revolution around, because we know that our solutions were supposed to be, we can include 0, go all the way up to 2 pi. So one revolution around, where do I find positive cosine values? All-star trig class tells me that the cosines are positive in quadrant 1 and also in quadrant 4. And so cosine being the very first value, it looks like it would be pi over 4 and also 7 pi over 4. So the solutions to this function would be pi over 4 and 7 pi over 4. Or let's add 1 to the opposite side. 4 cosine squared equals 1. Divide by 4. Now, in order to simplify that square, I'm going to take the square root. But remember, this is going to result in 2 answers. So the cosine of x equals plus or minus the square root of 1 over the square root of 4. The square root of 1 is 1, and the square root of 4 is 2. So I'm looking for both positives and negatives. Where can I locate those? So cosine is the first value. We can see 1/2 can be found at pi over 3. A negative 1/2 can be found at 2 pi over 3. These are all reference angles to 60 degrees, or pi over 3. Here's a negative 1/2 again. So 4 pi over 3. And also down here at 1/2 at 5 pi over 3. In example number 5, I'm going to divide by 3. Cosecant squared is equal to 4 over 3, excuse me. I'm taking the square root just like we did in example number 4. So the cosecant of x is equal to plus or minus, because we have 2 answers, the square root of 4 over the square root of 3. Now before I do anything else, I recognize that cosecant and sine are reciprocals. So the sine of x is equal to plus or minus the square root of 3 over the square root of 4. And the square root of 4 can be simplified to 2. So plus and minus. Where are the sine values equal to plus and minus the square root of 3 over 2? So sine is the second number. We can see that's right here at pi over 3. So our reference angle again is 60 degrees, or pi over 3. Here's another positive radical 3 over 2, so 2 pi over 3. Down here is another, no, this is the negative version. Remember, we have plus or minus, so 4 pi over 3 and 5 pi over 3. Let's go on to example number 6. Example number 6, this is factored form. And so I'm reminded that in factored form, I'm anticipating 2 answers. I'm going to set each one of these answers equal to 0. Why is that? Let's use x and y. If I tell you x times y equals 0, one of 2 things are true. Either x equals 0 or y equals 0, or maybe they both equal 0. That's why I'm going to set each one of these factors to 0. So 2 sine of x minus 1 equals 0, and then the sine of x plus 1 equals 0. All right, let's go ahead here and isolate the sine of x. I'm going to start by adding 1 to the opposite side, and then after that I'm going to divide by 2. Now there is no square here, so it's not a plus or minus. I want to locate where is the sine equal to a positive 1/2. All-Star Trig class tells me I'm going to look in quadrants 1 and 2. So I'm looking at pi over 6 and 5 pi over 6. All right, let's go on to the next part. Where is the sine equal to negative 1? Bringing this back up, sine being the second value, we can see it's right down here at 270 degrees, but in radian measurements, that's going to be equivalent to 3 pi over 2.